Good morning. I'm going to share a couple of things with you that are going to be useful as we continue our discussion on how hydrogen fuel is produced for hydrogen cars. So your goal today is to make sure you watch the entire video, write down whatever questions you have from this video for me, and then submit those questions through the Dropbox. So I'm going to jump right in here. How do you know when a reaction has taken place? So here are three clues that a reaction has taken place. Something new is visibly produced. If that happens, you know a reaction has taken place. If a gas is created, you know a reaction has taken place. And if heat is given off or if heat is taken in, you know a reaction has taken place. When heat is given off, that's called an exothermic reaction. When heat is taken in or heat is absorbed, it's called an endothermic reaction. As you've continued your research, you run into different types of chemical equations. So I wanted to also go over with you what a chemical equation looks like. On the left side, you have reactants. On the right side, you have products. The arrow symbol stands for yields. So here's an example. You have methane gas, CH4, plus oxygen gas yields. When these two react with each other, they yield carbon dioxide gas and water. So this is steam, H2O, but it's not in liquid form, it's in gas form. So G stands for gas. So this is steam, this is carbon dioxide gas, this is oxygen gas, this is methane gas. If you see a G, it stands for gas. If you see an L, it stands for liquid. If you see an S, it stands for solid. If you see an AQ, then it stands for aqueous solution. That means water-based solution, and that'll be helpful in understanding what a chemical equation looks like. This could also be read as in 1 mole of CH4, 1 mole of methane plus 2 moles of oxygen gas yields 1 mole of carbon dioxide gas and 2 moles of steam. So H2O, water, but in the gas phase. If you don't see a number in front, that stands for 1. If you see a number in front, well, that's pretty straightforward. The numbers in front are called reaction coefficients. So you have a reaction coefficient here and here. You also have one here and you have here. We just don't write the number 1. Here's a little breakdown of what I just now spoke to you about. The chemical reaction above, reactants, yield symbol, products. Here are a couple other examples. You have CH4 plus H2O yields carbon monoxide and hydrogen gas. You may have run into this equation. Another example is carbon monoxide plus H2O yields carbon dioxide and, once again, hydrogen gas. If you notice arrows are pointing in both directions, that means the reaction can go from left to right, but then it can also go from right to left. So that's called an equilibrium reaction when you see arrows pointing in both directions. Here, excuse me, here's a little extra information. O2 stands for a diatomic molecule. We referred to this before. Oxygen likes to combine with itself to create oxygen gas. Other examples are hydrogen gas, chlorine gas, and nitrogen gas, H2Cl2 and N2. All right, so as you did a little bit of research, hopefully you ran into the term hydrocarbons. So when you talk about steam reforming, for example, steam reforming starts off with methanol, propane, gasoline, ethanol, diesel, a lot of natural gases. And you must have run into the term hydrocarbon. So I want to go over what that means. Hydrocarbon is basically a compound, any compound that has hydrogen and carbon in it. So hydrocarbons are the chief components of natural gases and petroleum. An example is benzene. You've run into benzene before because last week you had an assignment on empirical, molecular, and structural formulas, and benzene was one of the ones that was used as an example. This is a structural formula of benzene. This is what the compound looks like. You have carbons in the center connected with hydrogens on the outside. This is a hydrocarbon. Here's another example. This is methane gas, and this is a 3D structural diagram where you notice that when I draw straight lines, that means that this is in the plane of the paper. When you notice I draw a solid triangular shape, this is me trying to show that this part is coming out of the paper. And when you see dashed lines like this is me trying to show you that this part is going into the paper. So this is a 3D diagram, or as best as one can do when you're showing compounds. This is just showing you the length, 108.7 picometers, and you can look up how much a picometer is compared to a centimeter or a meter. And this is showing you the angle, 109.5 degrees between the bonds. While you've done your research, I'm sure you've run into different types of reactions. As you've looked into hydrogen fuels, I'm pretty sure you run into this term, synthesis reaction. So I want to go over what are the different types of reactions. So synthesis reaction, or a direct combination reaction, is when two things are separate in the reactants side, but they combine together as they create a product. So an example would be sodium plus chlorine yields sodium chloride. Carbon plus oxygen gas yields carbon dioxide. 2 moles of calcium oxide plus 2 moles of H2O, 2 moles of water, yields 2 moles of calcium hydroxide. OH is called hydroxide. Whenever you see an OH, that's a hint that you may be creating a base. So the product may be something called a base. And when we get to acids and bases, that will become a little bit more clearer. But keep in mind, OH is referred to as a hydroxide. There are a couple other types of reactions. I'm going to share them all with you, even though you're not going to run into too many of these as you do as we continue discussing about hydrogen fuels, but I thought it'd be a good time to talk about them. So you have a decomposition reaction. Decomposition reaction looks like it's just the opposite of a synthesis reaction. Two things are together, and they break apart. So you have 2 moles of liquid water, H2O, yields 2 moles of hydrogen gas plus 1 mole of oxygen gas. That's a decomposition reaction. Single displacement reaction, you have 3 things, but then they end up changing partners. One of them changes partners. So B is with C, but on the product side, C is no longer with B. C has switched partners and gone to A. So an example is zinc, a solid zinc, plus copper sulfate. SO4 is called sulfate, sulfur and oxygen together. It's called sulfate. It's an aqueous solution, so it's water-based solution. Produces or yields zinc sulfate aqueous solution plus copper in its solid state. So this is a single displacement reaction. A double displacement reaction is when you have 4 items and both of them change partners. So A is with B, C is with D, but you notice here C leaves D and joins A, and B leaves A and joins D. An example would be silver nitrate, NO3 is nitrate, plus sodium chloride yields silver chloride plus sodium nitrate. Another example is barium chloride aqueous solution plus sodium sulfate yields barium sulfate plus sodium chloride. So AQ stands for aqueous solution. Aqueous solution is a water-based solution. L stands for liquid, S stands for solid, G stands for gas. A precipitation reaction is one in which a white insoluble solid is formed as the precipitate. So that's called the precipitation. So you have potassium chloride aqueous solution plus silver nitrate aqueous solution yields silver chloride solid plus potassium nitrate aqueous solution. So you have this white insoluble solid that's formed. That's why it's called a precipitation reaction. There are 3 other types of reactions that we'll get into as the year progresses, but I'm just going to share them with you right now. Please put them down in your notes and write down any questions you have. A neutralization reaction is an example when an acid and a base combine and they create salt and water. So here's an acid for you. This is sulfuric acid, and you have a base, sodium hydroxide. OH is called hydroxide. That's a hint that it's a base. Yields sodium sulfate plus water. This is L for liquid water. If you were to read this in moles, you could say 1 mole of H2SO4 plus 2 moles of NaOH yields 1 mole of Na2SO4 plus 2 moles of H2O. Now, instead of saying the exact every letter, you could say 1 mole of sulfuric acid plus 2 moles of sodium hydroxide yields 1 mole of sodium sulfate and 2 moles of water. This is an acid-base reaction. That's what's called a neutralization reaction. They neutralize each other and they create a salt and they create water. This here is your salt, this here is your water. Combustion reaction. This is what Captain Mellon was talking to us when he came and he spoke to us about from the firefighter's perspective. Combustion reaction is when heat is produced. So, and it's been off propane plus oxygen gas and then carbon dioxide and water. And once again, propane is a hydrocarbon because it's got carbon and hydrogen. You also have a redox reaction. Redox reaction is when you're giving off electrons or you're taking in electrons. There's an example right there. I do want to talk to you quickly about what an endothermic and exothermic reactions are when you're absorbing